All right, it's time to do the analysis. That was 12.5 seconds for 20 revolutions. So number of revolutions, 20 revolutions. The time, the time 12.50 seconds. And so I need to figure out how fast was that thing spinning. Well, there are a couple things I need to know on that. So first off, how far did it travel? If I'm assuming it's traveling at a constant speed, and it was roughly, assuming it's traveling at a constant speed, then I know that my speed is just going to be the distance over time. So I have to figure out the distance. Well, it was traveling in a circle. Well, what's the distance around a circle? Well, that's just 2 pi times the radius of the circle over time. And so what was the radius? Well, that's a measurement that should have happened beforehand. I'm going to estimate based upon what I have right here about where this thing was. So spinning it like this, it was just, so actually I think I was probably pretty close to it. The radius was basically, backing up, the radius was that piece right there, from there to that smaller mass. And so I have a radius of, now one of the questions comes up, where on this thing do I actually measure that? I should measure to the center of mass here, roughly the center of the object itself. So that is 65 centimeters. And so the distance it travels is going to be 2 times pi times 0.65 meters. Am I still on screen? Yeah, I'm still on screen. All right. And I'm going to divide by, well, that's 1 revolution, so I need to divide by the time for 1 revolution. And so I did 20 of them because, I don't know, it might have been a little bit off when I started. Stop. The more revolutions I do, the more accurate my answer is going to be here. And so that's the time for 20 revolutions. Let's put a little 20 down there. The time for 1 revolution is going to be 12.5 seconds over 20 revolutions. And if I do that math, I get 0.625 seconds for 1 revolution. And so over here I divide by 0.625. And so I end up with the speed. My speed of the object that's going around, again, not velocity because the direction is constantly changing, it's the speed. My speed is 2 times pi times 0.65 divided by 0.625 seconds. And I end up with 6.53 meters per second. That is my speed. Now, the analysis that you're going to do is going to be based on the graph. We've done graph analyses before, but I'm going to just do straightforward. Let's just see how close we get. I suspect we're going to be way off because the whole reason, because there is friction involved, which I've not taken into account here. There is the weight of the swinging mass, which I'm also not taking into account. But I'm just curious to see what happens here. So you'll be doing a graph to sort of average out all those eccentricities, all the other things that sort of seem to show up. Let me get some room here. So I have my speed. I know the weight of what's hanging off the end. I know that m1g is equal to m2v squared over r. And so it was a 100 gram mass at the bottom. So 0.1 kilograms times 9.8 meters per second squared. The numbers that I have here are not so precise that I need to take greater precision for the acceleration due to gravity. And so we end up with 0.98 newtons based upon the weight of the mass that was hanging down below. Over here, m squared v over r, that was 0.02. It was a 20 gram or 0.02 kilogram mass. Let's stick in the units. Times my speed, which is 6.5353 meters per second, squaring the whole thing, divided by my radius, which was 0.65 meters. And so on that one right there, let's plug into the calculator. And what are the chances this will come out right? Squared 0.02 times 0.65 divided by, and we end up on the right side with 1.31 newtons. I still have the equal sign there just for tradition's sake. However, obviously 0.98 and 1.31 are not the same. However, we're within, it's roughly 33% off. It's going to actually a little bit less, so somewhere around 30% off, which is not bad. That's a lot closer than I thought before I started this. But that's one way of doing the analysis. But again, your analysis is going to be a little bit different with the graphs, but that kind of stuff you have done before. If you have questions about doing graphs, please ask or see one of the other videos. And thank you very much.